day 311 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 204, count primes. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Question says, given an integer n, return the number of prime numbers that are strictly less than n. So, sounds simple enough, y'all, but let's go ahead and take a look at these examples so that we can make sure that we're doing this question correctly. So in example 1, we have the input 10. Input is 10, the output is 4. Explanation says there are 4 prime numbers less than 10. They are 2, 3, 5, and 7. So all they want us to do is they're going to give us an input in n, and whichever n is equal to, we want to find all of the prime numbers that are less than n. And in this case, n is 10, and there are 4 prime numbers less than 10, which are right here. So let's go ahead and look at example 2 and example 3, because they both might be cases where they try to throw some tricks our way. So in example 2, we have the input n equals 0. And since n equals 0, the output is 0. Boom. And then same thing with example 3, n equals 1. The output is 0 because there's no elements less than 1 or there's no elements less than 0 to that we can use to see if it's a prime number. So with that being said, y'all, let's get into the fun part, the actual solution. So the first thing we want to do is we want to initialize a counter, which is going to keep track of the prime numbers that we've encountered so far. So in order to do that, we could just come right here. We could declare a variable, call it count, and we could set that equal to 0 just to start. Boom. Now we're going to create a Boolean array, which is of size n. So whichever n is, that's how long the array is going to be. This is just going to be for a default value. And we're going to set all the values to true to start. And this array is going to help us track whether the number is prime or not. So if it's prime, it'll be true. If it's not, then it'll be false. So in order to do that, we could just come right here. We could declare a variable, call it primes. And we are going to set that equal to an array. Boom. Open up the parentheses. It's going to be repeating, colon, true. So it's just going to be an array of a bunch of trues up until count is going to be n. So however many n is, that's how many trues it's going to be in the array. However, this is just a default value. We'll mutate it as we continue in our code. So now we're going to declare another variable, and that's going to check from the first prime number, which is 2. So we could just declare a variable called I and set that equal to 2. And this will help us deal with cases like this, right, where the numbers are less than 2, right? Because the first prime number is 2, so that's why we're going to start with 2. Boom. So now we're going to come right here. We're going to say while I is less than n, we're going to open up the brackets. So if a prime I is still true, it means I is a prime number. So we're going to say if prime square bracket I, that should be square bracket. If prime square bracket I equals true, then we're going to open up the brackets and we can increment the count plus equals 1. Boom. Then we're going to come right here. We're going to start making multiples of I as non-prime. So we're going to say var j equals I times 2. So what this is going to do, right? So say this is going to go through each number up to whatever n is. So right. So say we're starting at 2. So it would be I times 2, or 2 times 2 would equal 4. So we know 4 is not a prime. So we'll mark that as is not a prime. Boom. And we're going to do that for each element. Then we'll go to 3. We'll do 3 times 2. That'll give us 6. Now we can mark 6 is not prime as long as the output is less than n, right? So then we'll mark it as, we'll do And we'll keep going. We'll do 4. 4 times 2, that's going to give us 8. So now we can mark 8 as not a prime. You know what I'm saying? And so on and so on. So once again, that's what this is going to do. We're going to multiply I by 2, and whatever the value is, or whatever we get from that, whatever the product is, then we can mark that product as it's not a prime. So after we do that, in order to do that, we're going to say while j is less than n, so it's only going to be numbers that are less than n. We're only worried about numbers that come before n, so numbers that are less than n. And this is how we're going to do it. We're going to say prime, we're going to set prime square bracket j, we'll set that equal to false. So once again, whichever j is, say I is 2, we'll take 2 times 2 times 2, that'll give us 4. So now j equal 4. It'll go to prime, find 4, and mark that as false, because now, and it'll let us know that it's not a prime anymore. Boom. Then we have to increment j and I. So in order to do that, we'll come right here and we'll say j plus equals 1. And then we have to increment I as well. So we could come right here and we could say I plus equals 1. Boom. Then we're going to come right here and we could just return count. And yeah, that's all we have to do, y'all. So let's go ahead and run it. Seems simple enough. Let's go ahead and run it. Let's go. Okay, what's going on here? It says cannot find prime. Oh, sorry. Well, let's just take the S out of this. It should be prime. It's not primes. So let's run it again. Oh, we got the wrong answer. So when you get the wrong answer, 9 times out of 10, that means the math is wrong somewhere. The math is not mathing. So let's figure out where we messed up on the math at. Oh, excuse me. This right here should be, j should be plus equals I. Sorry, not plus equals 1. So now let's go ahead and run it. See if this works. And there it is, y'all. It's accepted. So let's go ahead and submit it. Make sure it stays accepted. Let's see, and look at that, y'all. 91 milliseconds beats 72.84% of users with Swift. Not too bad at all. Those are some good numbers right there. They could be better, but we'll worry about getting those numbers better as we continue down our LeetCode journey. Right now, we just want to be able to solve the solution that is presented in front of us. So with that being said, y'all, get one more look at the code. One more look at the code, read it, learn it, love it. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.